Welcome to another day of section 2.2, day 5. So we're still working on other types of equations, introducing a couple new things today about extraneous solutions. At the end, there will be a problem that I'm going to ask you to do, and then when you come into class the next time I see you, I ask that we just go over that quickly and make sure we have no questions on that one. So let's get started here. We're going to solve these radical equations. Similar to what we've done in the past, it is a square root. So how you undo a square root is by squaring both sides. So normally we've gone the other way, but this time you now are going to take the square. This leaves the left side as x minus 3 equals 25. Add 3 over, x would equal 28. Now, one thing we have to be aware of is that we need to check our answer because of what's known as extraneous solutions. I'll read the definition for you right here. Squaring both sides of an equation or raising both sides to an even integral power may introduce extraneous solutions. So we need to check in the original equation. It doesn't take that many steps, so make sure you do take the time to check your answers. Looking at this, I want to plug 28 into the original problem. So 28 minus 3, I'm asking myself, does it equal 5? That simplifies to 25. Question mark throughout, and then at the very end, yep, 5 equals 5, so that is a true answer. Looking at the next one. Notice on the right side there's a square root. I'm going to undo the square root with squaring both sides. When you do so, you're actually going to have to FOIL the left. You can look at it like this. When you FOIL, you'll get x squared minus 2x minus 2x, so minus 4x. Plus 4. Let's move that x to the other side, because in order to factor, you have to have it equal to 0. Thinking about terms that multiply to 4, add to negative 5, x minus 1, x minus 4. I now have a product that equals 0. Set those both equal to 0. These would be your two answers you get. Now, before I just circle and say I'm done, I just squared both sides, so I need to check for extraneous solutions. That means we have to check both of these problems, both of these answers in the original problem. So my check, I'm running out of room. Sorry, I'm going to squeeze this up here. Okay, I'm going to first check 1. So if I plug 1 into the original equation, I want to see, is it true? Well, the left side is negative 1, the right side is 1. That is not equal, so x equals 1 is not a solution. Let's check 4. If I plug 4 into the original equation everywhere I see an x, I'm asking myself, are they equal? 2 equal 2. Yep, that is true. My only answer is x equals 4. Simple check. You need to do so, otherwise if you said the answer was x equals 1 and x equals 4, that would be incorrect on a quiz, homework, test, anything. Okay, so a little properties about extraneous solutions. I kind of already talked to you about that. When you square both sides, you need to check if it works. Otherwise, they're called extraneous solutions. So for example, 2, x equals 1 is extraneous. Multiplying both sides of an equation by an expression involving the variable may introduce extraneous. We'll talk about that. Therefore, it is necessary to check your solutions. Super important. Saves you answers. Okay, so we have two examples and then I'll let you be done. So this is part A, walking through here. If we had the equation 2 plus square root of 10 minus x equals negative x, first thing you would do is isolate the radical by rewriting the equation as such. In other words, subtract over the 2. Now, the left side has a square root, so to undo the square root, square both sides. Kind of hard to see there, sorry. When you do so, the left side becomes very nice. The right side you will have to FOIL like we did in example 2. Make it equal 0. Factor. And then these steps is the zero product property, or ZPP. You squared both sides, so you're going to check your answers. So I left a little check here for us to do that. You're going to take the answers of -6 and 1 and plug into the original equation. So originally it was 2 plus square root 10 minus x. Well, x in this first case is -6, so notice how I wrote that, equals -6. I want to know if this is true. Well, I get 2 plus square root of 16. Does that equal 6? Square root of 16 is 4. I would like you to get all the way to this last step and show me left equals right, check mark. That means this is a solution. Now we need to check our other one. Go to the original equation again. This time plug in 1. Is this equal? Put a question mark because it is not equal yet. We don't know. It'd be 2 plus the square root of 9. Question mark. 2 plus 3. I'm already noticing this is not going to be equal, but I want you to get all the way to this point. Left side does not equal right. So that means x equals 1 is not a solution. So notice, hence the only possible solutions are -6 and 1, but the only real solution, the only one that actually is an answer, is -6. You have to check. This one's possible, but once you check, you realize it's just -6. Then part B is a very fun one to talk about. You can make your life super easy or pretty miserable. Let's go the easy route. I'm just rewriting it for myself. I see a square root. My instant thought, let's square both sides. If I do so, that right side would be really nice. I would have to FOIL that left side. Not a fan. It's definitely possible, but that's going to be a lot of work and a lot of potential areas to make mistakes. So instead, I'm going to move over one of these square root terms. It will not matter which one you move over. So I'm going to decide to move the 2 square root of x minus 2, like so. Now, when you take the square root, your right side, you do have to FOIL, but it's not as bad as if there was 2 square roots. The left side, luckily, becomes pretty nice. And let's walk through this FOIL for the right. I'm going to actually move this over, give myself some more space, because a lot of mistakes can be made if we're not careful. I'm going to rewrite it as the 2 terms so I can really truly visualize, that should be a 2, my FOIL. Okay, take my first term times my first would be 1. First term times my last term would be plus 2 root x minus 2. Root 2x minus 2 times 1 would be plus 2x minus 2. Now the last step is multiplying 2 square root x minus 2 times 2 square root x minus 2. So I'm doing this step right here. It's my last FOIL. That becomes 4, the 2 times the 2. And then when you multiply 2 square roots together, you end up with what was inside the square root. Think about if you multiplied root 5 times root 5. You would end up with just 5. So in this case, you end up with just x plus 2. Keep in mind you have that 4 being multiplied in front. So this is just extra. I'm going to erase it now, but that's the same idea you're thinking of. Okay, this is the left side. Now we're combining like terms. I'm going to distribute here. I get 1 plus these are like terms. So I have 4 x minus 2's in a square root. I have plus 4x and a minus 8. Going to combine some more like terms. I notice the 1 and the negative 8 can combine. And I can actually move them to the other side. Oh, that will be nice. Move actually a lot of things. Oh, this will be really nice. So 1 minus 8 is negative 7. Add 7 to both sides. I would get 10 over here. Move this 4x to the other side. I'll get negative 2x. And this will be what's left over on the right. So there's a couple steps in between there. Make sure you understand those. If you don't, please ask during class. Now this looks like a normal problem we're given. Let's divide both sides by 4. Oof, if I do that, I'm going to get some fractions on the left. Not ideal. Instead, what if I divide by 2? This will at least make my answers a little more simplified. I would end up with a negative x plus 5 equals 2 square root of x minus 2. This step is truly optional, the dividing by 2. You could divide by 4, but I don't want to have a fraction on the left side. If you leave the 4, it would be the same exact problem. Notice here, we're going to have to do the same thing anyways. You have a square root, so I'm going to square both sides to get rid of that. You just can't forget that there is a 2 in front. That also needs to be squared. A lot in this problem, right? Okay, we're going to FOIL the left side. And we're going to FOIL the right side. Or if you can visualize it, each term, no, let's not visualize. If you can visualize it, great. If not, that is okay. I want this to make sense to everyone. When we FOIL the left side, I end up with negative, so I learn x squared minus 10x plus 25. This one, the 2's on the outside will multiply together to get 4. Just like before, if you multiply a square root of x minus 2 times the square root of x minus 2, you just get x minus 2 in parentheses. Let's distribute those. Now let's get it equal to 0. I end up with negative 14x. Oops, I would add to a 33. We're getting there. Hang in there. X minus 3, x minus 11 would factor nicely. I do a zero product property, so set each term equal to 0. And these are my possible answers. Now, whoa, look at that, mathematicians. Sadly, I put squares on both sides. I squared both sides, which means I cannot just assume that these are right. Let's check our answers. I'm just moving into this bottom area. Sorry, guys. But we're going to check both answers into the original problem. So the original problem was root 2 times x plus 3 minus 2 square root x minus 2 equals 1. I need to see if this is true for x equals 3. When you do so, that's 6 plus 3, that's 9. This would be 1. I have that question mark. 3 minus 2, does it equal 1? Please get all the way down to here. Apologize. 1 equals 1. So I know x equals 3 is for sure a solution. We have to check x equals 11. So same thing. Plug in. This time, everywhere you see an x, put an 11. And put that question mark. Is it true? I don't know yet. 22 plus 3 is 25. This would be 9. Question mark. 5 minus 2 times 3. I'm noticing this is not going to be right, but I need to get all the way down to the end. -1 does not equal 1. So this is not a solution. You will see something like this on homework and on assessment, so please make sure you take your time, follow all the algebra. It's really just a lot of algebra thrown in here. Okay, so just take your time. For homework, I would like you to give this problem a try. I will check this at the beginning of class. Check at beginning of class. So to prove that you watched your video, you need to have this whole problem completed with work. And in the end, I'm going to tell you, your final answer should be x equals -2/3. Okay, make sure you try this on your own. Show all the steps, show all the algebra, show your checking step, and then we'll confirm that we all got the same answer when we come to class. Good luck, people. You got this.